Good morning, everybody. Today, I would like to present before you the counseling session on the electric and hybrid vehicles, which is going to be one of the open elective offered by the Department of Electrical and Electronics for the 6th semester students. There is no bar for any student for his branch, his or her branch to select this subject, except the electronics and communication branch. The subject now, as it becomes a dominant one, very significant one to study, because see, these automobiles constitute an integral part of our everyday life. Environmental as well as the economical issues provide an inclination towards a clean, efficient and sustainable vehicles for the transportation. Exhaust emissions of internal combustion engine vehicles give rise to carbon footprints and the global warming. As the oil reserve of the world is depleting very fast, there is a need to choose alternative to the oil, and it is addressed by electric vehicles. Electrical vehicles need to be driven by an appropriate battery or a storage device. Electrical vehicles are becoming manufactured by the automobile industries recently, but the number is limited and the production cost is a little high. Electric vehicles, when integrated with a petroleum or a diesel engines, are known as hybrid vehicles. In the next decade, it is certain that the most of the automobiles would be electric vehicles. But however, hybrid vehicles also, till then at least, are going to play the major role. The subject deals with the present technology of electric and hybrid vehicles, the challenges at hand, and the issues in future. The subject emphasizes the various battery technologies and their management strategies, with electric vehicles serving as a zero-emission vehicles and the hybrid vehicles already filling in for ultra-low emission vehicles. The subject is promising in terms of new technology and can offer more career opportunities in automobile sector, which is the biggest industrial sector. The power management in electric vehicle has been revolutionized since old power structure introduced with the first electric vehicles. Today, it can be powered either by a single or a combination of multiple sources and driven by a single or combination of multiple algorithms. This enhancement contributes in significantly better results. And if we consider the factors in designing the hybrid vehicles, or the vehicle characteristics, driving cycles, vehicle configuration, maximum speed required, maximum torque attainable, maximum power delivered, battery capacity, battery voltage, etc. And one of the important requirement as well as embedded in the syllabus is the motor characteristics. We are going to study the different electric motor characteristics and see the traction motors or types of motors that help in the moment of propulsion of vehicle. This kind of motors are commonly found in electrically powered rails and electric vehicles such as electric cars, as well as the vehicles that employ electric transmission system or to transfer the power. The motor is the most important part of the electric vehicle, and therefore the selection of the motor is extremely crucial and needs to be done with a deliberation so that the vehicle can perform admirably. Many criteria such as cost, performance, efficiency, power density, and maturity of our technology, and how easily it is to control the motor play an important part in the selection of motor. There are many types of motors available to us. Motors are broadly classified as a DC and AC motors. Simply put, DC motors work on DC voltage, AC motor works on the AC voltage. It is imperative that we study more about these motors in detail and find out more about the properties of each kind of motors and see how suitably it could be used as the motor in the electric vehicle. It is also important to study how the motors compare to each other, how they are with its own properties are set. And this is a typical example of an electric motor. And many types of motors we are going to study, and I have put up a typical diagram here. This is the entire motor here, and this is a stator, and this is a rotor here. End rings are there, and see this runs as the electric motor whenever a power supply is given through this box. And the hybrid, to talk about the hybrid vehicles, hybrid vehicles can be used for a regenerative braking, which captures the energy normally lost during the coasting or braking. It uses the forward motion of the wheel to the turn of wheels to turn the motor. This generates electricity and helps a slow vehicle. The capability of regenerative braking is one of the reasons why the renewed interest has been shown in these such motors. Electric motors or a drive. The electric motor provides a power to assist the engine in ascending, passing, or hill climbing. This allows a smarter, more efficient engine to be used. And in some hybrids, the electric motor alone propels the vehicle at low speeds, where the gasoline engines are least efficient. Automatic stop or start and automatically shuts off the engine when the vehicle comes to a stop and restarts when the accelerator is pressed. This reduces the wastage of energy from idling. You can just see this is one of the schematic diagram of the hybrid vehicle here. This is the internal combustion engine. This is the electric motor and the battery are there, and the generator has been placed in between here, and which drives the entire the vehicle. Okay, so this is a combination of IC engine and the battery driven generator. And to look into the syllabus, we are going to learn in the first chapter of first unit, introduction to hybrid and electric vehicles. We are going to study a brief history of hybrid and electric vehicles, social and environmental importance of hybrid and electric vehicles, impact of modern drivetrains on energy supplies, types of electric vehicles in use today, and electric vehicles for the future. And next one is this is a hybrid electric drivetrains. This is one of the important concepts that what we are going to study as far as the mechanical power transmission system is concerned. Basic concepts of hybrid traction, introduction to various hybrid drivetrain topologies, power flow control in hybrid drivetrain topologies, fuel efficiency analysis. And the next one is you are going to study about the electric motors, introduction to electrical motor and components used in hybrid and electric vehicles, configuration and control of DC motor drives, configuration and control of induction motor drives, configuration and control of permanent magnet motor drives, configuration and control of switched reluctance motor drives, and drive system efficiency. Next one is sizing of the drive system, matching the electric machine and the internal combustion engine, sizing of the propulsion motor, sizing of the power electronics, and selecting the energy storage technology, communication, and supporting subsystems. As here now we are going to have only the qualitative analysis, not a quantitative. That is, there are no numerical problems here. We are going to have a set of equations, and after that some flow charts, and the tables to be matched and such things, and you are going to write the study the qualitative analysis of this the sizing of the drive system. Next one is the batteries, types of battery parameters, capacity, discharge rate, state of charge, state of discharge, depth of discharge, technical characteristics, battery backup design, properties of battery, and the battery management system. And this is followed by the case studies. Few of the case studies will be presented here. Design section, and as well as for electric vehicle and electric battery electric system. Okay, and these things are there. And these books now, which are having written in the textbooks or reference books, all the books we are going to have e-resources are taken from NPTEL, and everything will be provided here. You need not to go to because each one is around a 300-page book. We are going to have the relevant chapters or a relevant subject and gather all together and in the form of notes it will be given. And this nearly takes around 30 hours to get finished. And subject is almost it runs theoretical. And I think it is going to be useful in your future. Thank you very much. If you have any problem, you can directly call me, and or else you can put me a WhatsApp or something here. And I'm Dr. D.R. Joshi from electrical department. You can come to AF2, and I will be there. You can find me there, and let us have a discussion, more discussion. Okay. Thank you very much.
Uh, Good morning, everyone. Today, I'm going to give the introduction on the our second open elective, which is being offered by the electrical department. That is industrial automation using IoT, and the course code, subject code of this particular subject is 18EE 661, and it is a 3 credit course, like other open electives. And the main objective of this particular subject is. First is we should understand the basics of IoT digitization and different IoT architectures which are available in market or which are recognized worldwide. Okay, so those architecture and all we're supposed to understand, and then we should understand how exactly the smart objects. Okay, it is to be prepared and how exactly it is to be work, and also we're supposed to discuss about the how we can implement this IoT in the different industries. So means for the different industries, different architectures or objective of the industry will be different, the targets will be different. So with respect to that, it is. And then the last objective of this particular subject is LoRa IoT platform. Means in this we are going to discuss about the one particular hardware, that is a LoRa, and we are going to use the network LoRa WAN. So we are going to discuss more and more about this particular IoT platform. Okay, so this is the main objective. Means from this subject, we are going to study about the basics and architectures of IoT, and regarding the smart objects and sensors, actuators, and how exactly it is to be implemented in industries and LoRa IoT. And coming to the syllabus, in the first unit, we are going to discuss more about the introduction to IoT. Means what is IoT, how the evolution of IoT has come, and then what is the difference between IoT and digitization, and what is the impact of IoT in the different industries, and what are the challenges, okay, we are going to face it in implementing the IoT, and which are all the network architectures which are available, and the motivation behind creating the new architectures. And then mainly two types of architectures we are going to discuss. Okay, one is a IoT IoT World Forum architecture, and another is a MTM, machine to machine architecture. Two architectures we are going to discuss in the first unit, and both the architectures are recognized throughout the worldwide. And then we are going to compare those architectures, and then by combining both the architectures, one simplified IoT architecture we are going to discuss. And then these functional stacks and data management stacks, these are the components of those architectures which are present in the both the architectures. So in the first unit, it is more about the introduction to the IoT. So the basics of IoT we are going to discuss. And in the second unit, engineering IoT networks means regarding the smart objects and sensors, classifications of sensors, how exactly these sensors will be working, and classification of actuators, and how to integrate these sensors and actuators to make these smart objects, and then the sensor networks, and then how to connect these hardwares. Okay, so hardwares with respect to the smart objects, and then communication criteria. Communication criteria means um, here we are going to discuss about minimum some 6 to 7 different wireless technologies. So means communication criteria means all the standardization, then the stacks, which all the stacks will be present, which are all the MAC layer, then physical layer, all the layers and security aspects, and pros and cons of those particular wireless networks, and all we are going to discuss in communication criteria and IoT access technologies. So means in this second unit, we are focusing more towards the sensors, actuators, and communication. Okay, so and in third unit, so your third unit is IoT in industries, means application. So application means IoT, how to implement the IoT in utilities. Utilities means it is a basic supply chains, means it may be water distribution, electricity distribution, or gas distribution. Okay, how to implement this IoT in these kind of utility industries, the architectures, then objectives, then which kind of networks are best for this kind of industries, that we are going to discuss. And same thing in the smart and connected cities, means in the smart cities, how to implement the IoTs. Okay, so what is the architecture and networks and the challenges, objectives, everything related to the smart cities we are going to discuss. And same thing in this transportation and public safety, means IoT in industry. In the third unit, we are going to discuss about the four different industries. One is the utilities, smart and connected cities, transportation, and public safety. Okay, so this is about the third unit, means the application. Okay, so in the first unit, it is the introduction. Second is basic components and the smart objects. Third unit is this application. Okay, and then in the fourth and fifth unit, what exactly we are studying is here LoRa IoT platform we are going to study in detail. Means there are many IoT technologies which are present in market, so we can make use of the node MCUs or ESP432 we can use, or even 8051 microcontroller chips can be used, or there are hundreds of different IoT platforms are there. Out of that, we have chosen this LoRa IoT, okay, for this subject. And here, so we are going to start with introduction to LoRa and LoRaWAN. LoRa means long range. Okay, means this particular IoT platform, okay, it can support up to 10 kilometers. Okay, so if I place a gateway 10 kilometers away from the workplace, then also we can do the means we can achieve the work. Okay, means if it is a Bluetooth, means it will be having a range of only 10 meters. Within the 10 meters, we should keep the projects. And if it is a Wi-Fi, means it will be having a range of 100 meters. Like that, this is a LoRa means long range. So up to 10 kilometers, it will be supporting. Okay, so here, what is LoRa, the meaning, and then modulation techniques. Okay, which modulation techniques this particular LoRa will be using? That is amplitude, frequency modulation, frequency shift keying, means all the basic, and even the CSS we call, that is a chirp spread spectrum. And in this, out of this, this LoRa make uses of the chirp spread spectrum. In order to study this, we need a basic knowledge of amplitude and frequency modulation and frequency shift keying. So all the concepts are there here. And then here together we call it as, so means if we implement this chip spread spectrum in the LoRa, it will be called as LoRa spread spectrum modulation. So that particular modulation technique we are going to discuss. And then applications, okay, where all we can make use of this particular LoRa platform, means projects. And then network coverage, then the low power wide area networks, means the kind of network which it will be using, LoRa. Okay, that one we are going to use. And then LoRaWAN means long range wide area network, that also we are going to use. And then here in the second part, we are going to discuss more about the hardware. So that is a end device. End device means the last component which is being connected with the sensor side actuators. Okay, which kind of hardwares can be used for end devices, which kind of hardware can be used for gateways, and then which frequencies are best for the LoRaWAN. Okay, and then advantages, disadvantages, and hands-on experiments also it is mentioned here. Okay, so we are having the kits. Actually, we are having the LoRaWAN kits. So if the time permits, so we are going to give the hands-on experience on this particular platforms. Okay, and then in the fifth unit, it is a continuation of same fourth unit. Okay, so here we are going to discuss the difference between the LoRa and LoRaWAN architectures. In architectures, again, there are three classes are there: class A, class B, class C. So how these classifications are done. Okay, and all the aspects related to LoRaWAN architecture we are going to discuss in the first part of the fifth unit. And in the second part, it is more about the network server and application servers or cloud servers. Okay, so what is the network server, what is the cloud server, and related to the security. Okay, how to give the security to this particular projects. Okay, so regarding this, there are two types of securities are there. That is activation by ABP and VOTA. That is over-the-air activation. Okay, these two methods in details we are going to study, and then how to improve the quality of data transfer. Okay, with respect to that, this signal strength indicator and signal to noise ratio. Okay, these all we are going to discuss. Okay, this is about the 15th unit. Okay, so in this subject, okay, first 3 units are with respect to introduction to IoT, and then hardwares used in IoT, and then applications. And in last 2 unit, one particular platform we are going to discuss. And then which book can be taken for this particular subject is that is IoT Fundamentals by the Cisco Publications, or even the IoT Internet of Things by Signage Publications, or this beginning to LoRa radio networks with Arduino, that is a APRES. The best book is the Cisco Publications, so it is available in our library. So we can make use of this particular textbook for this subject. Okay, so this is about the uh, briefing about this particular subject which we are offering from the electrical department. So, by this, I will hand over the session to our next faculty. So he is going to explain about the fuzzy logic.
Hello everyone. My name is Professor Rahul Suryavanshi, and I will be handling this subject, fuzzy logic. This is the open elective subject which has been offered by one of the open elective subject which is offered by the Department of Electrical Electronics Engineering. Now, when we are talking about this subject, fuzzy logic, so first of all, let us understand what is fuzzy logic. Now, when we are talking about fuzzy logic, the word itself says it is a logical subject. Now, this is used basically to solve any kind of problem which has ambiguity and uncertainty. Now, when we are talking about, for example, let us just take when I say that orange, whether it is a fruit or whether it is a color. So there is an ambiguity in the system. So still, if you want to find out which, so still, if you want to understand what exactly is the questions, for example, I'm asking you whether it is a fruit or whether it is a color. So when I just say orange, the question or the problem has a lot of ambiguity in it and lot of uncertainty. So when we are solving such kind of problems, we always go for fuzzy logic. So fuzzy logic is basically a logical subject. It is not a coding. It is not a what we can say. It is not a programming subject. It is a logical subject which is being used in order to perform various aspects. So it is used to perform. So it is basically used to perform various types of not moving. Oh, sorry for the inconvenience. Yeah. So the thing what I was telling you is with respect to the logical subject. Now this is a logical subject. Now we can use the logic. So for example, what is the logic? Logic is nothing but, so when I am saying 2 plus 2 is equal to 4 or 2 3s are 6. So what we are doing, the logic behind is multiplication. What is the logic behind the multiplication? We are adding 2 3 times. So that is the logic. So we are basically going to work on the logic, not on the programming language. So you can use any kind of language, C, C++, Java, whatever it might be. We can be using these languages to, by using this logic, we can implement it in any type of language, or what we can say, it can be used for any kind of problems. Now, where exactly this, let us just focus on the point where exactly this fuzzy logic can be used. See, as I told you, fuzzy logic is used where the system is very much complex in nature. That means what there should be a large amount of difficulty in the system. For example, if I say, as I give you the example, orange. So when I say orange, you don't know whether it is a color or whether it is a fruit. So a system which is having a large amount of ambiguity and uncertainty in it, that time we call it as that time we go for a fuzzy logic. There are various applications. For example, what we can say is temperature control, or there are traffic signal control. Then we have for washing machine. Practically in various research domains, it has been used. It is used in various applications by various industries that we are going to see in the next this thing. Now let us understand what we are trying to tell you here. See, fuzzy logic deals with something called as a degree of truth. Okay. Now, what is the degree of truth here? When we are talking about, for example, when we say that uh, uh, every statement has certain degree of truth. Okay, so whether it is 100% true statement or it is a 0% true, so there is a degree of truth in it. So that is what we are going to deal with it. Now, coming to the next thing, for example, as I said, you cold water is cold. Now, water can be cold. So when we talk about, you might have studied regarding the classical set theory. So classical set theory deals only between 0 and 1. Okay, so either it is, so it can say that your basic system, so if you just use a conventional programming system to find out whether the water is cold or not, so what it will do, it will say either it is cold yes or no. That means 1 or 0. So your system deals only between 0 or 1. So there is a step type of system. Now, but in terms of fuzzy logic, when we give the problem statement in fuzzy logic, so for example, is it cold? So here we are saying, so is it cold? Now in this case, what will happen? We have various degrees of truth. So it might be very much cold, it might be little cold, or it might be very less cold. So in this case, the earlier conventional system had only 0 or 1, wherein in the fuzzy system, we have the values between 0 to 1. So it is a ramp. So it is a ramp what we are talking about. Whereas the conventional system is a step signal. So in this fuzzy logic, we are going to learn much about the ramping type of system. That means what? There is always a degree of truth. So in this case, either it is cold or it is not cold. So there are only two conditions. Here there are multiple conditions. So it can be very cold, it can be extremely cold, it can be chilling, it is very much very cold. So human language. So basically fuzzy logic deals in a human based language type of system. So when we talk about if I ask you what is the today's temperature, you might say that it is a pleasant temperature. Okay, so fuzzy logic deals in a this type of system wherein we use human based type of system. So you can see these adjectives have been used very much, very, so slightly, very. So these type of things are used in fuzzy logic. Next, so understanding again further. So as I said, you traditional or basic logics only work between 0 or 1. So either it is a true system or a false system. In this case, as I said, your degree of truth. So a system can be 70% true, 30% false. Yes, or it can be 10% true, 100%, 90% false, or it can be 100% true and 0% false. So there is a degree of truth in everything. So that is what is the fuzzy logic. Now, where exactly fuzzy logic is used? Now, it is used in variety of industries. What we can say is this, as I said, this is a logic, and logic can be implemented in anything, whether it is a technical thing, non-technical thing, anything. So it, as you can see here, when we focus into the engineering industries, so aerospace industries, they are using it to for altitude control of spacecraft and shuttles. So for basically in landing control or takeoff control, the angle with which the blades have to move, all such kind of things can be controlled using fuzzy logic. Then in electronic industry, so electronic industry, they are designing washing machines. So the washing machine is one of the major application for fuzzy logic. So if you just see LG or IFB type of washing machine, fully automatic washing machine, the processor, the controller is designed using fuzzy logic. Then in electrical industry, switchgear and control of power grids. So for optimal power flows, for optimal switching control, everywhere we can use fuzzy logic for this thing. Then in automotive industries nowadays, as the technology is booming up with what we can say, electric vehicles, speed control and all those things are going to be a very vital thing. And in these type of speed control, there is a large amount of research which is going on, wherein fuzzy logic is used for controlling the speed. Then we can use it for traffic controls. Then this is part of the electronic or can say engineering industry. It can also be used in the management sectors. For example, in decision making, suppose that we can use fuzzy logic in making decisions. For example, suppose that you have a product which has been developed, and depending upon its market potential and its what you can say in the degree of innovation which is involved in that thing, we can find out where this product can be launched within a country, or whether it can be launched in few of the states. So such kind of studies can be done also in using fuzzy logic. Then in chemical industry, wherein controlling the pH, drying, chemical distillation process, etc., it is used. And the most important thing is fuzzy logic is used in artificial intelligence. So you might have seen nowadays that machine learning, everything is ANN, all these things are booming up, and fuzzy logic is one of the major part which has been played in these kind of artificial intelligence systems. Now, so to just give you an overview of how this can be used in one of the application, we have considered one application of obstruction detection. So, for example, the one thing what we need to understand is fuzzy logic is used in a system wherein precision requirement is not much. Okay, so this cannot be used for target hitting. For suppose that you are having a target wherein actually a missile has to come and hit that target, you cannot use fuzzy logic. Fuzzy logic is not 100% accurate. It can be made up to 80, 90, 95, 99% accuracy, but it cannot be used for what you can say where the precision required is very high. But if the precision requirement is not that high, fuzzy logic plays a very vital role, because for a system which do not have any kind of or which has a large amount of ambiguity, which does not have a proper data, still if you want to find out the answers, in that case the result may not be 100% accurate, but whatever result you are getting will be precise, so that nearly correct. So that is the reason fuzzy logic is used. Now for example, when obstruction detection, let us see this thing. So there is this vehicle is a fuzzy logic controlled. So what is going to happen, there will be using an image processing, or there is using the sensors. This vehicle is going to find out what is the distance between the two vehicles, and then automatically the brakes will be applied. Now it is not mandatory that the vehicle has to stop at a particular distance only. So but it has, the objective is that this vehicle should not collide with this thing. Okay, so the fuzzy logic can play a very vital role in identifying the objects, identifying the, what you can say, the distance, and approximately applying the brakes in such a way that the vehicle stops at a particular distance without any collision. So this can be done. So that is what is so nowadays in ADAS and all those things they are using. The next is nothing but when we talk about where exactly this fuzzy logic is used, the fuzzy logic is used in various industries. For example, ABB is using fuzzy logic in controlling into the cement industry. Then this, as I was telling you regarding Samsung, LG, and IFB are using fuzzy logic for designing their washing machines. That is a fully controlled automatic washing machines. So you can see these things here they are using. So if you just go on to their page, you can see that this is fuzzy logic controlled. Now, considering the opportunities for the students after learning this subject, this is what we have seen. Just in Bangalore itself, recently we have seen that there are a lot many companies which are requiring people who have skills in fuzzy logic. So these things were taken. Another thing example is Tata Steel is also using fuzzy logic for pattern recognition to find the deformations and all the things. So nearly majority of the R&D industries are using fuzzy logic for their work. Okay, so this is the overview of the subject. Now when we are talking about the content of the subject, so in this subject we are going to learn regarding various aspects of how exactly we are going to design the fuzzy systems, how we can perform. So there is a method of doing something called as a fuzzy normalization, then there is a fuzzification, then there is how to use the inference engine, that is nothing but how the rules have to be formed, how it has to be implemented, how it has to be defuzzified. So there are certain things the pattern has to be understood. So those things we will be studying and understanding in this chapter. The first 3 units will be understanding regarding the concept of how exactly the fuzzy logic and what are the details of the fuzzy logic. The fourth unit is with respect to the applications, where we are going to study various applications such as how to design the this thing. How to design a washing machine, how to design a traffic control signal. So how the controllers can be designed. What is the, see, we are, as I told you, we are not going to study anything regarding the coding part. We are going to design the logic for the entire system. Okay, so the last unit will be the advancement which are there in the fuzzy logic, that is nothing but the adaptive fuzzy. So this is the content of the syllabus, and these are the, as I said you, this is one of the most important subject in which is used in research and development. So if you just go on to the IEEE website and see, there are around 35,000 papers which are been which are there on this on the net, on their site, which is using fuzzy logic, or where the fuzzy logic has been used. Okay, so this is what we would like to say regarding the fuzzy logic. So thank you everyone.